Hey guys, we are in section 3, chapter 3, section 1, where we are talking about statements and quantifiers. So in this video, we will talk about defining and identifying statements, defining the logical connectives, writing the negation of a statement, and writing statements symbolically. So a statement is a declarative sentence that can be objectively determined to be either true or false, but not both. So a statement is a declarative sentence that can be determined to be either true or false, but not both. Okay. So in the English language, there are many types of sentences. These are the different types of sentences. However, when we are talking about statements, we are looking for those factual statements that can be determined to be true or false. Okay. So let's look at example 1. It says, decide which of the following are statements and which are not. So which ones can be and which ones are declarative statements that can be identified as either true or false. Most scientists agree that global warming is a threat to the environment. We can determine if that's true or false. It's a declarative statement. Is that your laptop? That's a question, so it's not a statement. Man, that hurts. That's an exclamation, so that's not a statement. 432 plus 8 divided by 13 equals the square root of 115,000. We can determine if that's true or false, so that is a statement. This book is about database management. This can be determined if it's true or false, so it is a statement. Watching reality shows turns your brain to mush. That is an opinion, so it is not a statement that we can determine true or false. Yeah, we cannot determine it true or false. Just an opinion. All right, next we have simple and compound statements. So simple and compound statements are exactly what they sound like. Simple statement contains one idea. Compound statement will be two simple statements put together. Okay. When we put those two compound statements together, we are using a connective. Those connectives are called conjunction, disjunction, conditional, or biconditional. Each of those have a specific word that we will see in the sentence. So we will see and for a conjunction or for a disjunction, if then for a conditional, and if and only if for biconditional. So let's look at some examples. Here we see John studied for 5 hours and he got an A. That's conjunction. I'm going to pass this class or I'm going to change my major. That's disjunction. If I get an 80% on the questions, if I get 80% of the questions on the LSAT right, then I will get into law school. That is conditional. We will win the game if and only if we score more points than the other team. That is biconditional. So that's how we will see our compound sentences being created. Okay, example 2. So we are looking at classifying each statement as simple or compound. If it's compound, we have to figure out what connective was used. So our school mascot is a moose. That's simple. There's no connective there. If you register for Wi-Fi services, you will get 3 days of free access. Well, we see this if, and it's conditional, if then, and so that's compound. Letter C. Tomorrow is the last day to register for classes. That's simple. It's one idea. And letter D. In the interest of saving the planet, I plan to buy either a hybrid or a motorcycle. It has or, so that is compound. All right, so quantified statements. We have quantified statements are split into two categories. We have universal or existential. Okay, universal quantified statements deal with the words all. My pen not writing. Come on. All, each, every, no, or none. And then we have our existential quantifiers that have the words some. Oh, sorry. Pen is acting up. Some, there exists at least one. Okay. So our universal, the way I remember is universal, I'm thinking about everything. So universal deals with all, each, every, no, none. Okay. It's either all or nothing. And then existential goes to some extent. So we're thinking some, there exists at least one. So here are some examples of the quantified statements. Every student taking philosophy this semester will pass. No nursing student is also majoring in criminal justice. Some people who are Miami Hurricane fans are also Miami Dolphin fans. There is at least one professor in this school who does not have brown eyes. Okay, so let's see if we can determine which statements these are. I see the word every. So every is going to make me think universal. I see no, that's also universal. I see some, that is existential. And then there's at least one is also existential. All right, next we have what's called the negation. Okay, a negation is the negation of a statement is a corresponding statement with the opposite truth value. This means that if the statement is true, then its negation will be false and vice versa. So a good example would be my dorm room is blue. The negation would be my dorm room is not blue. Okay, you cannot say, however, my dorm room is blue. You cannot negate my dorm room is blue by saying my dorm room is yellow. You cannot pick a different color or a different idea to negate the statement because both of those could be false. So your dorm room could not be blue and it could also not be yellow. It can be a different color. So to negate the statement, my dorm room is blue, you have to say my dorm room is not blue. Okay. Here goes some more examples of negations. Auburn will win Saturday. Auburn will not win Saturday. I took a shower today. I did not take a shower today. My car is clean. My car is not clean. Okay? You have to be especially careful when negating quantified statements. Consider the example statement, all dogs are fuzzy. It's not quite right to say that the negation is all dogs are not fuzzy, because if some dogs are fuzzy and others aren't, then both statements are false. All we need for the statement, all dogs are fuzzy, to be false is to find at least one dog that is not fuzzy. So we can negate that statement by saying some dogs are not fuzzy. Okay? Here's a good negation chart to follow. Okay? If our original statements contain these words, then we can negate it with these words. Okay? So all do, negate with some do not. Some do, negate with none do. Some do not, negate with all do. And none do, negates with some do. You can also see that they used different words here, but it's all the same concept. So let's look at some examples of that. Example 3 says every student taking philosophy this semester will pass. Well, let's negate that by saying if we're starting with every, we're thinking all, so we can negate that by saying some will not. I'm not going to write out the whole statement, but some students taking philosophy this semester will not pass. So some will not. Letter B says some people who are Miami Hurricane fans are also Miami Dolphin fans. Okay, well, we're starting with some, so we need to negate it by saying no people who are Miami Hurricane fans are also Miami Dolphin fans. Letter C. Let's say no people, just not no. There is at least one professor in this school who does not have brown eyes. So if we're starting with there is at least one, we can go to our negation of saying all. All professors in this school have brown eyes. All professors have. Okay. And then letter D says no nursing student is also majoring in criminal justice. Well, if we're starting with no, we can negate it by saying at least one. Okay. Once again, all I did was use this chart. I just didn't scroll back and forth. You should have had your notes open, and I just used this chart to look at what my statement contained and negation. And those can be flip-flopped too. If it contains this, then that would be my negation. All right, let's go on to talk about symbols for the connectives. So we've already talked about our different connectives. We've already talked about the names of our connectives. Now we are being introduced to the symbols for our connectives. So simple statements in logic are usually denoted with lowercase letters like P, Q, and R. For example, we could use P to represent the statement, I get paid Friday, and Q to represent the statement, I will go out this weekend. Then the conditional statement, if I get paid Friday, then I will go out this weekend, can be written with if then, so that's conditional. It can be written with the arrow. If P, then Q. Okay, then we have a tilde here. That represents a negation. So if P still represents I get paid Friday, we call this not P represents I do not get paid Friday. We often use parentheses in logical statements when more than one connective is involved in order to specify an order. Okay, right now we're just going to focus on writing out these simple statements. Well, they're compound statements, but we're going to focus on writing out these compound statements. So let's use the symbol P to represent the statement large coney is a dog, and Q to represent the statement Guinness is a cat. Letter A says, what does the statement not P and Q mean? Okay, not P. So we're going to look at our P, which is large coney is a dog, and we're going to have to negate that. So to negate large coney is a dog, we're going to say large coney is not a dog. And Q, which is Guinness, is a cat. Okay, so that's what we were just saying in the first part. We were just looking at those parentheses first, and then we are compounding it or using the connective to go with the other part. Part B says, what does the statement not P and Q mean? Now we have to negate the whole statement. So we first have to look at P and Q, which would be large coney is a dog and Guinness is a cat. Now we need to negate that whole statement. It is not that we can say something like, it is not the case that large coney is a dog and Guinness is a cat, because we're looking at negating the whole sentence. So we can say, it is not the case. Large coney is a dog and Guinness is a cat. Okay, so we negated that whole statement, whereas here we just negated that P. All right, moving on. Example 5. Let P represent the statement, it is cloudy, and Q represent the statement, I will go to the beach. Write each statement in symbols. Okay, I will not go to the beach. Well, I will not go to the beach. Not going to the beach is Q, and I see the word not, so I'm going to negate Q. It is cloudy, and I will go to the beach. It is cloudy, that's my P, and I will go to the beach. So, and is my up arrow. If it is cloudy, then I will not go to the beach. This is a if then, so I know that it's a conditional. If it is cloudy, then I will not go to the beach. So I'm negating my Q. I will go to the beach if and only if it is not cloudy. I will go to the beach if and only if it is not cloudy. So this is biconditional. And I can say, I will go to the beach, which is Q, if and only if it is not cloudy. So I'm going to negate my P. Okay? All right. Now we're going to work the other way. If this is your dog, which it's not because it's mine, statement E describes it pretty well. Write each statement in words. Let P equal, my dog is a golden retriever, and Q equal, my dog is fuzzy. So if it says not P, then we can say, my dog is not a golden retriever. It says P or Q, you can say my dog is a golden retriever or my dog is fuzzy. I'm not going to write the whole thing out, but we're going to use or there. The biconditional statement, not biconditional, the conditional statement is not P, so my dog is not a golden retriever. If my dog is not a golden retriever, then My dog is fuzzy. Okay. Letter D is the biconditional. That's the if and only if. So my dog is fuzzy if and only if my dog is a golden retriever. I'm shorthanding, yes, but you guys get the point. And then this last one, Q, my dog is fuzzy and my dog is a golden retriever. Okay, so that sums up section 3.1. Lots of good information in there. Here are your discussion questions. Make sure that you're reading over them and that if you have any questions, comments, or concerns, you are writing them down and email.